In this last example, let's just go and do 3v, or 3u minus v. So in this one, just to kind of go a little bit quicker, I'll just do the math. I'll distribute a 3 here real quickly. So I'll say 3v. And a lot of times, ladies and gentlemen, I would recommend, or 3u, I would just recommend doing this. So therefore, doing them separately. So that's 6 comma negative 3. Does everybody follows? And then one that I'll also do is a negative v. And the reason why I want to do a negative v is so therefore I can combine. I can combine the two vectors. You could do it. You could do it either way. But now I can basically say, like what I did was I basically did this. I did plus a negative. Does everybody see what I did? Why I did that? I always like adding a negative. So I just did plus a negative, because I like adding rather than subtracting. So if I plus a negative, I can do the negative, which is distributing a negative. I can distribute a 3. And then my 3u plus a negative v is now just going to be the combination of these two. So that's going to be 2, negative 6. Does everybody see that? OK, well, hold on just one second. Do you see what I did by distributing this negative 1? I split it up into 2 different problems. And by distributing the negative 1, it just made my math simpler. And then I'm just rewriting this as an addition problem. Because everybody would agree with me that 4 minus 3 is the same thing as 4 plus a negative 3. Correct? So rather than doing it individually, I just said, well, you know what? Let's do 3u and let's do negative v. And then let's combine them. So now I have 2, negative 6. So there goes 1, 2. And then this is 1, 2, 3, 4, 5, 6. All right, let's look at it. Again, do you guys remember when I did? Remember vector addition, right? Vector addition is going tail to head, correct? So let's check my work. Let's do 3u. Does everybody agree with me 3u is 6 comma negative 3? Does everybody agree with that? OK, so let's graph 6, negative 3. 1, 2, 3, 4, 5, 6, negative 3. 1, 2, 3. Because regular u is just 2, negative 1. Right? That's u. That's 3u. Everybody agreed? OK. Now, what is negative v? We know v is 4, 3. Correct? What is negative v? Does everybody agree with me? Negative v is negative 4, negative 3? OK, so let's take a look at where negative 4, negative 3 would be. Negative 4. 1, 2, 3, 4, negative 3. 1, 2, 3. That's negative v. Because positive v is 1, 2, 3, 4, negative 3. Right? That's v. Wait, negative 4. Oh, that's 3 up here. 1, 2, 3. Sorry. That's positive v. That's negative v. Does everybody agree? So if I rewrite this as addition, how do I know? All I do is do tail to head, right? So I literally take the tail of this vector negative v, and I put it right there. Does that look like, roughly, it's about the same as negative v? Yes. Yes.
So why don't, OK, see, the way I did it was I kept the 3 out, and then I did the subtraction in there.
And then multiply by 3?
Yeah. Why can't you do it that way?
Because you're not subtracting, because that's like doing this. Can't do that, right? You multiply first. Or think of it as order of operations. Multiplication before addition and subtraction. So you have to apply your multiplication first. Does that make sense? Anybody else have any questions? No? Everybody feels okay?